Hi, I'm Cassie, and I'm going to walk you through question 18 of the AAMC's official physics question pack. So again, this question is related to passage 3, which is all about understanding the Doppler effect. Remember, the Doppler effect says that when two objects are moving relative to one another, then if one object is releasing waves and the other object is observing or measuring some quantity of those waves, like their frequency or wavelength, the observed frequency or wavelength is going to be different than the actual frequency of wavelength. So again, all about relative motion, changing perceived frequency and wavelength. So here, we want to figure out basically if a star is approaching the Earth or going away from the Earth. And what we're given is the wavelength of the star measured in the lab. So when things are measured in the lab, they're in these controlled environments, right? So we're going to think of that as like the actual wavelength of the star, or the source wavelength of the star. And then they also measure the wavelength that they're getting from the star. So we need to compare that wavelength that they measured to the actual wavelength of the star and see whether it's lower or higher, and then use the Doppler effect to figure out what that means. So our lab wavelength, you notice, is 6.563. They're both raised to the same power of 10 to the negative 7th. So we don't need to worry about what they're raised to. But here in our lab wavelength, our third decimal is a 3, versus in our measured wavelength from the star, our third decimal is a 1. So what does that mean? Well, it means that our lab wavelength is going to be greater than our measured wavelength. So this means that the wavelength that we measured from the star is smaller than the actual wavelength of that star. So we've had a decrease in wavelength. So off the top of your head, you might not remember what that means in terms of the Doppler effect, whether it means that our objects are getting closer or farther away. So always think back to that example of the ambulance with the siren. So if you're in traffic and that ambulance is getting closer relative to you, then you're going to hear that sound as more high-pitched. So basically the perceived frequency has increased, okay? So I always start with that example in my head, and if you need to, you can even write it down. So when two objects are getting closer, you're going to have an increase in the perceived frequency, which, of course, since frequency and wavelength are inverses, according to our formula, velocity equals frequency times wavelength, right? If frequency increases, then our perceived wavelength must decrease. So that's exactly what we have happening here, right? We said we have a decrease in our perceived wavelength, so our objects must be getting closer together. So that star is coming closer to Earth, so the answer is going to be D. Of course, we could have had the opposite case, right? We could have had our objects were getting farther away, but that would have been if we had a decrease in perceived frequency, which would correspond to an increase in our perceived wavelength. So again, notice that all these questions about the Doppler effect, I haven't used that equation you find in the Kaplan book for the Doppler effect once. You just need to have the conceptual understanding. If you can remember that ambulance example and remember that you have to have relative motion for the Doppler effect to occur, that's going to take you about 90% of the way for everything you need to know for the Doppler effect for the MCAT. So I hope this helps. If you like this video, please drop a like and subscribe to this channel for more videos like this.